Good morning, good afternoon, and good evening. Thank you everyone for joining. Today we're all in for quite a treat here. We have Trevor Gent from Illumichem, and he's going to be presenting on sludge management in RAS. Now, this topic gets people excited. So thank you, Trevor, for presenting today. And Trevor, you're the director of engineered solutions at
Yes,
Illumichem.
it's that is my official title is Director of Engineered Solutions.
Yeah, that is a good title. So you're a chemical engineer,
Correct.
studied at University of Alberta.
I did.
It's in Canada,
hmm
um, home of the Edmonton Oilers.
Correct.
Is
Much to my dismay.
Yeah, I was wondering if it was too sensitive right now.
No, it's okay. I'm far enough away living in Denmark that it's okay.
Yeah.
I can deal with the topic.
Yeah. Okay. Okay. So they just got knocked out of the Stanley Cup playoffs. Um, and now you live in Hersholm.
Yes, the
Most people
huge
on the webinar.
metropolis. Yeah, the
Yeah.
huge metropolis. Everybody
Yeah.
knows where Hersom is.
Yeah.
Absolutely.
Yeah. Probably people know where that is. So a bit north of Copenhagen in
Correct.
Denmark. I was actually there once. I was visiting a
You
friend.
you you actually came to Hersom,
Well, I
or
drove
you've been
to
to
to get
Copenhagen?
to, is it um Cook Cookadal?
Oh,
Just north
Cockadale.
of
Yeah,
you?
yeah, Cockadale.
Cookadal.
Yeah, yeah. Okay, that's
Yeah. So I
basically
drove
Hersom.
through.
Yeah,
Yeah.
yeah. Very
Hey, you're
nice.
close to Roskilde.
Yes, yes.
Does
It's
the festival still exist?
Roskilde Festival with the Naked Run still exists. Very important festival.
Okay.
Very, very, very popular amongst
Okay.
the young
Yeah.
ones. Not so much in my age.
Yeah. It was popular like when I lived in Denmark 30 years ago. It was popular then.
Yeah, yeah.
Still
It's
going.
still a
Going
big
strong.
thing. Yeah, yeah. No,
Nice.
it's a
Yeah.
it's a massive, massive thing. So,
Yeah. Um, okay. So you're the director of engineered solutions, which maybe you can, and it sounds better than director of fish manure.
yeah,
Or
it really does. Yeah. So as a director of engineered solutions, ultimately is we at Illumichem, we are a water treatment based business and predominantly on the chemistry side was our focus. Then we realized it's of value to get into the engineering side of things. And so we started building up our engineering team. And as the director of engineered solutions, my role is to focus on the commercial and design side. And then there's a team that goes out and executes the actual projects. So I'm on the front end. What are we trying to achieve? And then there's a whole group out there that focuses on how do we achieve it.
okay, okay. Yeah. So that is something I think that's super important in where we're headed now in the land-based um, industry and we were chatting a couple of months ago about fish poop, obviously.
hmm
Uh, and we were talking about this modular hub and spoke RAS farm model that's being developed by Habitat Farms in British Columbia and Canada. So
hmm
their concept enabled distributed salmon production by partnering with up to 20 different First Nations or terrestrial farmers. And these partners would operate a standardized 300-ton spoke facility growing coho salmon,
hmm
150 grams up to harvest size, 3.5 kilos. And so there was a centralized hub that provides the critical inputs and services. And so the spokes would be located close together within 100 kilometers for operational integration and logistics. And the model is designed to remove some key barriers to entry in land-based aquaculture. And that's what manure is. Fish manure it's a barrier to entry in handling that.
Hmm.
So Habitat was going to provide their plans to provide the spoke operators with standardized farm design, engineering, construction oversight, um, operating protocols and training, supply of smolts, technical and monitoring support, uh, harvest logistics, processing, and market access. But then when we were talking about that, but what about the poop? And that's what I wanted to know from you that's one of the barriers to entry for land-based aquaculture, how to handle the fish manure,
Hmm.
and then how can a centralized hub support that? And you thought that, hey, that would be an interesting topic for a webinar.
I did, and
And
that's
here we
it's
are.
definitely it's been kind of a topic of discussion amongst a lot of the sort of people that I've been discussing fish with over the last 4 years since I got into the world of aquaculture is should you go big or should you go small? And
Mm,
this is sort of that brilliant combination of both. So I thought it would also be worth doing a webinar that was a little more narrowed down in terms of what we were trying to discuss and what we were bringing forward, um, and a little more relevant instead of just coming in and saying, "Hey, look, this is how you do wastewater treatment, and this is how you deal with the fish manure, and this is how you deal with the excess food, and so on and so forth." So, just trying to be a little more design focused in terms of what we're talking about and what we're looking at.
mhm.
Um, so should we get started or is there any other housekeeping that you wanted to look after?
Well, we have there's a Q&A box down at the bottom of your screen, and so if you have questions. You can type them uh, into the Q&A box, and we'll see how timing goes and see how many we can get through throughout the presentation here.
And see how much Trevor and Justin just talk with each other,
Yeah,
which we're
that's right.
we're, we're known to do.
That's happened
Uh,
before.
yeah, exactly. So this time we have some slides instead of just the podcast, Justin. So this should be a little more entertaining
Yeah.
in the process. So, uh, just a quick background on Alumichem and why this is relevant in our space before I delve in. As I mentioned, Alumichem is a water treatment company. We do wastewater treatment. Ultimately, what we're looking at in a RAS facility is the end of pipe treatment. And I like the way that you call it as a barrier to entry in terms of dealing with this product. Because it's a twofold barrier to entry. One is getting your environmental permit approved that says, yes,
Hmm.
you can go produce this fish and you can discharge water. Um, but that creates a barrier to entry that says, oh, hold on, I have to actually produce water that's of a certain quality. I can't just spit it out. I can't just get rid of it. So it is an interesting barrier to entry, and it's one that we take really seriously. That it's the environmental discharge permit that drives how we execute that process in terms of treating the water, the discharge from the RAS facility. The hub
Right.
and spoke model was really a little bit more intriguing to me, especially after I'd spent some time in the south of France at friend's olive oil, or sorry, olive farm. And we went and picked all
Mhm.
the olives, put them into baskets, and then went to this cooperative where they took the olives and turned it into olive oil, and we got our olive oil back. And I went, okay, well, this is really interesting as a model, and that's sort of what the hub and spoke fish model sort of translated to me is this olive oil or wine cooperative that they have in France, and it's like, okay, now we can take this and turn it into a fish farm process, which became a little more interesting.
Mhm.
Because the spoke advantage means that you've got these individual fish farms that have independence, which I think is still really important in this space. We're also going to minimize the impact of the wastewater treatment and some of the dewatering. We're going to maximize the cost performance, maximize the dewatering, the cost of transport, et cetera, like that. But then at the hub, we're going to deal with the centralized processing, and from both sides. Again, you talked about
Hmm.
they're going to do the smolt production, they're going to do the sort of the initial design, and here you go. Um, but there can also do wastewater or solids drying at a localized position, which we'll talk about as we go through this. But ultimately,
Hmm.
what you get is that cooperative benefit of keeping CapEx and OpEx in line from that perspective. And also, the biggest factor I think when I think of the oil cooperative or the wine cooperative is you get the economy of scale of distribution, right? And I think that's the other aspect of this is can a local single farmer actually get access to the big market? And that's another factor that this kind of strategy brings to the table.
Hmm.
So
Yeah.
when
I
we're
really
dealing,
like that
sorry,
comparison to the olive farmers, and I think there's probably a lot of in terrestrial agriculture. I think there are similar models in play, and uh,
yeah.
to allow the sort of the smaller farmer to be able to compete.
Well, how do you compete against the big guys, right?
Hmm.
And you still have a good product, you still have a good process. It's just, how do I get that access to the market? So,
Hmm.
yeah.
Yeah,
I mean, I like the comparison because I get to go pick olives in the south of France, but woe is me.
it's a good part of it.
I feel so bad for myself. Um, but when we're dealing with RAS wastewater, and what I mean by wastewater is this is in a RAS system, you're going to collect some of the excess food and all of the feces in a drum filter or some kind of filtration system. We're then going to backwash that, and that is your discharge. Now, in that, you're typically high TSS, you have excess phosphorus, you have high nitrogen loads, other contaminants are typically in there that you're going to look at is BOD, COD, and how do we manage the process? And ultimately, anything in wastewater is about minimizing the contaminant stream, if you will,
Hmm.
or in the case of fish farming, it's concentrating the nutrients into one place would be another way of looking at it. It's the more positive
Hmm.
way of looking at it. But at the end of the day, we're trying to meet that environmental discharge permit, which is what the barrier to entry ultimately is, right? Um, at the end of the day, they don't care what you do with the excess feed or the fish manure. They just want the water to be clean.
Hmm.
So
Yeah, and you're right about that. I see you note there the discharge standards, which seem to be different everywhere. So
100%. Doesn't
yeah.
matter where they can be different from community to community.
Hmm.
And it gets
Yeah.
really interesting. I know in Canada you have sort of the environmental agency from the federal government, but then each province has their own environmental standard. And then in BC,
Hmm.
you've got an even weirder situation where the BC government they didn't like what they were doing, so they kicked them out, and they have to use the federal government.
Yeah.
It's really
Yeah.
weird, right? And it changes everywhere.
Hmm.
And it's a serious pain in the ass at the end of the day.
Yeah, yeah, yeah. And here in BC, it's even weirder than that because your water discharge is provincial. There's a provincial regulation you have to meet,
Yeah.
unless you have a permit. So you could have a permit instead, and then reach some other requirements. So
But that's the whole point,
it's
right? Is
convoluted.
there's a rule until there isn't a rule, and
Yeah.
then the rule changes, and yeah, and it's
Hmm.
super complicated. At the end of the day, the fish farmer just wants to make fish, and they want
Yeah.
to know that they can deal with the wastewater side of things, right?
Yeah. Yeah.
So the other part that's really important when you're taking that waste product or perceived waste product, you want it to be as cheap as possible in terms of disposing it. And by cheap, I mean transport. I've got to move it from my site to somewhere else. So I want to have as little
Hmm.
water in there as possible, but I want it to still be usable. I want it to still be pumpable. So we're going to talk a little bit about, what are the steps that we would do there to make that happen. So in terms of the basic process at Alumachem, what we would do is we would take that discharge water. So you're going to take the backwash from the drum filter. It's going to be typically somewhere between 0 and 1% solids, probably closer to the zero than the one. We're typically dealing in ppm.
Hmm.
And then we want to concentrate that up, right? So we would do a chemical treatment process to remove the solids, remove the some of the precipitates like the phosphorus, take the BOD, COD down, and we want to thicken it through a mechanical separation. Then we're going to dewater. And then in this case, what we're looking at is drying at the hub. But ultimately, it's a process of reducing the discharge process, but making sure that we get the most water back into the system. And that's really the key from my perspective. So from
Hmm.
a chemical treatment perspective, and this is really where Alumachem brings the largest amount of value is getting rid of the TSS, the phosphorus, BOD, COD, and a portion of the nitrogen. And what that means is you're adding a coagulant, you're pH adjusting, and you're flocculating. So if you're watching the video that's playing there, basically the graduated cylinder on the left side is no treatment. So that's what the fish sludge looks like. If we don't treat it, this is what it will look like, and it will eventually settle, but do you have the time to let it do that? Usually we don't. So what we would do is chemically treat it so that we get the proper separation. We would also precipitate your phosphorus in that process. We'd remove a large portion of the COD and the BOD and more nitrogen than you would expect. But at the end of the day, to get rid of the nitrogen, it's usually dissolved and it lives in a RAS system as nitrate because
Hmm.
you're going through the nitrification process typically in a RAS system, and it lives as nitrate. They convert the ammonia to nitrate, and then we have nitrate that flows through the system. If
Hmm.
we need to denitrify, again, that's plausible. We're not going to talk about it today because it's an extra step that needs to come in. When you're looking at the physical treatment, basically this is where we're going to try and separate that solid and liquid. Or if you look at the bottom, you get your fish sledge and you get it to that beautiful, nice clumpy solids on the bottom there. We can use a
Hmm.
drum thickener, belt filter, lamella separator, dissolved air flotation. They're just different mechanical ways of separating solids and liquids, right?
Hey, did you speed up that video? It looked pretty quick.
It was very, yeah, it's very sped up. Thanks for pointing that out. I appreciate that. Yeah, no, it was sped up. Because otherwise we'd be sitting here for another minute and a half. It's still fast, but
Yeah.
it's not as fast as I may have portrayed it.
No.
Is this where I have to say some images might be larger than you'd expect in the mirror? Is that what we're is that what we're getting at here,
But
Justin? No.
it all happens within a few minutes.
It does. Yeah, it does
Hmm.
happen. It does happen relatively quickly. But again, I think
Yeah.
the key in the physical separation point is if we just go with a settling tank, it takes a lot longer than if we speed that process up by using either a drum thickener, belt filter, a lamella
Hmm.
separator, or a DAF, right? You're just enhancing that process so that you can shrink the footprint down ultimately,
Yeah, yeah,
right?
and that's that can be a really expensive part of it that settling
Yes.
is
Yes.
the price of concrete has gone up significantly over the last years here, and
Well, the
to build
land
these
isn't
big
cheap either.
settling basins is.
Yeah, land isn't cheap either, so you'd rather have another
Hmm.
fish tank than
Hmm.
a big settling basin, right?
Yeah, yeah.
Um, and then dewatering, mechanical removal of water, decanter, screw press, or filter press. So if you look at this now visually, on the left of the screen, we have a drum thickener. Basically, we take that nicely flocculated water, we put it into the drum thickener. The picture in the middle is what it looks like in the drum thickener. This is going to be at about a 5 to 8% dry matter. And this is fish poop and excess fish food in the photo. And then what at 5 to 8% water dry matter, you got to remember we're at 92 to 95% water. Do we want to transport at that level? Probably not. So we look at the
Hmm.
dewatering step, which means in this case, this is fish sludge that's come out of a decanter. This is a 25 to 26% dry matter. Basically, it's formable. It looks like a mud ball at
Hmm.
that point. super transportable, super easy to move forward in terms of disposing to the next step. Now, if we wanted to look at drying, which we've talked about in this case, to put a dryer at each facility just doesn't make sense. The capital expenditure is too high. The dryers aren't small enough, so you're going to be way oversized. The footprint goes up. There's just a lot of factors that just say, okay, this doesn't make sense for the small facility. But it does make sense when you get to the hub, right? So now we look
Hmm.
at drying at the hub, and essentially what we're going to do is each of those spokes is going to take their sludge to 20 to 25% dry matter. They're going to stick it in a big bag and they're going to ship it to the central facility.
How
The
long does
central,
that take, Trevor? Like that
the dewatering
on your
process
previous slide there. Yeah, when you're getting the solids out of a drum filter, and then how long does it take to go through
from
these
from
steps?
start to finish, it's about 15 minutes
Yeah, okay, so it's
of
not.
this process. Yeah.
Hmm. So then it shouldn't in the picture that looks like that's going to be pretty smelly business. But
It,
if it's that short, it's
it's not
probably
that bad.
not doesn't smell yet.
Yeah, it's not that bad. Don't get me wrong, there's still odor.
Hmm.
It's not it's
Yeah,
not for the
but it
faint of heart, but it smells honestly just a little stronger than the fish farm itself in
yeah.
reality, right?
Yeah, like when
Um,
as long as it doesn't go anaerobic,
correct.
then
Yes.
it kind of smells more like soil.
Yeah. It's not actually that's it smells like wet dirt. That's a great
Hmm.
analogy. It kind of smells like wet dirt. Let's remember it's still a concentrated waste facility or concentrated discharge facility, depending on
Mm.
how you want to look at
Nutrient.
it.
It's a nutrient facility.
Concentrated nutrient facility. Sure.
Yeah.
I like that. I like that as well. Um, but what we're going to try and do is collect it so that each farm only has that sitting on their property for a certain period of time so the odors don't accumulate, so we don't have that big issue. But when we get to the
Hmm.
final drying stage, now we're going to reduce from, 20 to 25% dry matter up to 90% dry matter. And what that does is that does then hygienize it, right? So the smell does get killed because the bacteria drops off, the bacteria gets killed. So we're going to collect everything from the outer spokes and bring it into the central, and they're going to do the thermal drying. And now again, we use something called a low temperature dryer, which means we're not generating steam. We use low temperature air that takes heat from a waste heat pump, so we can use it
Hmm.
for different purposes. But we use a heat pump uses waste heat or generic electricity. 70 degrees. In the dryer, it takes longer. It does stay in there for an hour. That makes sure that it's hygienized. But the advantage to it is what comes out at the top here. Basically, what you see is that mud ball now gets broken into like a spaghetti string. Okay,
Hmm.
almost. It drops onto
Yeah.
the belt. Hot air flows up through that belt as it goes to the back. The first belt goes to the back, the second belt comes to the front, and this is fish sludge as it comes out at 90% dry matter. So it's like a pellet.
Okay.
So that pellet then gets collected in a big bag as and can be stored for
Hmm.
any length of time necessary.
Yeah. I
Now the
really
hope.
like that part of it because if you are in Alberta, for example, or
Hmm.
somewhere north where it gets pretty cold and it's
Hmm.
frozen all winter, you can't at an earlier stage, some of these you can spread on fields and so on, but
Right.
not when they're frozen.
Well, most farmers' fields, it's tough to spread onto ice or snow,
Hmm.
or
Yeah. So this you get
you
it
can
in
store for a
big
period of
bags,
time. Yeah,
and
exactly.
yeah, and then you can transport it, you can truck
Yep,
it.
yep.
Yeah,
Very mobile,
yeah, I really like that.
very, very, very storable.
Hmm.
Um, so now what we want to look at is, okay, so we've talked about what we're going to try and do. Now I thought let's put this into actual sort of, a attainable numbers of what this really looks like. So, as you mentioned, we've got 20 independent RAS farms, each producing 300 tons of head-on gutted um, coho salmon, correct? Coho?
Yeah, starting
Okay.
with coho. Yeah,
All
that's right.
right. So again, using basic sort of principles of the process with an FCR, that's your number, of
Mhm.
1.2. It's about 1150 kilograms of feed, which translates to dry matter of 250 to 300 kilograms a day. Okay. So
Hmm.
that in essence translates to at each spoke, you're going to have 2 to 5 cubic meters of water. That is super manageable in terms of a wastewater flow, in terms of equipment, in terms of flow rates, in terms of process. 2 to 5 cubic meters an hour is the sort of perfect world. If you were then to look at this the other way, if this was a big farm, that would be 40 to 200 cubic meters an hour. That's a massive variable in terms of what that looks like, right? Like that's a completely different ball game, right? Like if you're at 40 cubes, yeah, it's
Hmm.
manageable, but 200 cubes an hour, that's a big facility.
Hmm.
You're taking up a huge amount of space. Now let's look at that a little bit differently in terms of that total dry matter. At 5% dry matter, I'd have to transport between 5,000 and 6,000 kilograms a day. At
Hmm.
20, it's 1250 to 1500. At 25, it's 1000 to 1200. Okay, so let's assume we're somewhere between 20 and 25% dry matter, and we collect it in a 1 cubic meter big bag. Okay, so I've got one big bag, maybe one and a half big bags that I'm collecting every day. Very manageable as a farmer. I take it, I stick it aside, right? I don't want to keep it on site too long because it will start to smell. It will
Hmm.
start to go anaerobic, but very manageable in terms of what you're dealing with. We're then going to take those bags and ship them to the hub. Okay, so the hub on a conceptual daily basis is going to get to 20,000 to 30,000 kilograms per day of sludge. Okay, which is now a large amount of sludge, but they didn't have to do the pre-treatment and have, this 200 or 40 cubes an hour to 200 cubes an hour of water coming at them and do all of the pre-treatment. They just get this 20% dry matter at 20,000 to 30,000. We're then going to dry that to 90% dry matter. Well, now all of a
Hmm.
sudden that's, 275 to 350 kilograms a day that they're disposing of. So basically, if you think about it this way, each hub gets to get rid of a big bag, and then each spoke is going to get rid of a big bag every day, and then the hub is going to get rid of a big bag every day.
Hmm. Yeah.
Much more
Yeah.
achievable,
So,
right?
it looks really manageable when you get down to those numbers. Uh,
Exactly.
Now, I wouldn't say that they're going to dispose of it. They're going to
No,
sell
they're
it.
not. And the number's slightly higher now that I do the math in my head. It's not 275. It's 2750 to 3500. I'm missing a zero on that. But
Yeah.
again, you're not in a position where it's very manageable in
Yeah.
terms of the process, right?
Yeah.
And it makes a lot of sense to be able to put this forward. Again, like I say, one bag becomes one big bag, which is much more
Hmm.
achievable through that process.
When
To
when you
to
go up to Trevor, just on the
Yep,
middle box there on that previous slide, you
yep,
when you're on that um, when you look at that first 2 to 5 cubic meters an hour of discharge wastewater, and then you concentrate that to 5%. I
hmm
think that at a small farm, um, that's the that's where you get this. Barrier to entry that you have 6 tons a day, six
yep,
cubic meters a day of this, and
yep.
and of course it's building up every day, and the farmer's going,
Now
holy
what?
crap,
Yeah,
what am I gonna do? Like
exactly,
I got to get
exactly.
rid of this every
Yep,
day, or
yep.
it's gonna be overwhelming. And so that's, it's kind of um, the great part about farming in RAS is that you get to collect the nutrients, and then
Hmm.
the negative part is that you collect the nutrients, and then now you've got them. You go, holy, I got to do
Now
something.
what? Yeah, yeah, exactly. Well, and
Yeah, it's a big
if
challenge.
you're thinking you can just call the farmer and spread it on land and do this with it, absolutely you can. But the problem with doing the farm spread is you're 100% reliant on the farmer
Hmm.
and the farmer's need for that. And they don't always need it. They don't always want it. They don't
That's right.
necessarily want your waste stream,
Yeah, there's only a
right?
couple seasons that you
Even
want
though
that.
it's a positive for
Yeah.
them, they don't, they're not always looking for that because they're growing a different crop or the crop is laying fallow or there's something else going on, right?
Hmm. Yeah.
Um, so yeah, you're absolutely right. That is the complicated barrier to entry. So in this process, what we're trying to do is remove that issue by centralizing the drying process, right? And that
Hmm.
makes a big difference. So
Yeah.
just to look at this in a sort of more graphical perspective, right? And again, we've only got three spokes here because it didn't make sense to put 20
Yeah.
around the outside.
Yep. No, that's good.
Picture gets a little bit big, but you can start to understand what you're doing. And I
Absolutely.
love my marketing team. They put Illumicam's branding on the hub facility. We're not going to own the hub facility, just so you know. But that's the concept. Is this is going to be the large centralized point, but
Hmm.
that gives us a very different value recovery and end market with that perceived waste product, which is now can be turned into a nutrient product, right? We can use it for fertilizer. We can use it as an alternative fuel in cement plants potentially. We can use it for biogas production. We can look at pyrolysis as to create syngases. There's a lot more availability to us when we actually have a large amount versus again looking at, a small amount at a facility. What does one little farmer do with this little tiny amount of waste product? Or a nutrient, what is a high nutrient product, but ultimately becomes a waste product because nobody wants 100 kilograms. They don't, I can't do anything with 100 kilograms. I can do something with
Hmm.
7,000 kilograms. I can't do anything with 100, right? It's this economies of scale concept that puts it into play there,
Hmm.
which makes it change. But the main advantage is digging into um, you know, the valorization pathways and, the transportation costs, right? To transport at 20% dry matter is significantly more efficient and you're transporting less water. And so, I mean, this is always a complicated concept for people to get their heads around. It's not a linear graph in terms of water reduction when you're
Hmm.
talking about transportation, right? So if you look at, graphically, the difference between 20% dry matter and 90% dry matter, it isn't that significant in terms of, the volume or the mass of it. It is significant when you're trying to return that water and transport that water in the long run, right? And I think
Hmm.
that's really what it means in there. And again, just looking at the valorization pathways with that 90% dry matter, you do have the potential of fertilizer production, alternative fuels, pyrolysis, or incineration. But to kind of think about the economic model, and I think this is where I'll draw you in a little bit more, Justin, to this, is that efficiency of scale of utilizing big knowledge versus small knowledge, if that makes sense, right? Like you're going to have Illumichem provide a wastewater treatment design and plant for 20 places,
Hmm.
right? So there's economies of scale in terms of acquisition. There's economies of scale in terms of engineering design. There's all kinds of wins there just on the wastewater treatment side. And then imagine that on the fish farming side, which is usually the larger component of CapEx and OpEx in the whole thing.
Yeah. Yeah, it's I think that's a huge value to the to the model here. And when we talk about um, costs, like on the previous slide there, you're talking about decreasing the transportation volume. Of course,
Hmm.
that's decreasing the transportation cost. And
Yes.
I think that cost has been not just the transport, but all of the handling has been a challenge for the smaller, which isn't that small, but these RAS facilities. Um, it's been a challenge to figure out what to do because for me every time I've gone to look at it, the size has been too small. They go and oh,
Hmm.
you're way too small to
To bother with.
to build this infrastructure
Yep.
for the manure handling.
Yep.
So it does, it really opens the door for
But
that.
it also, it also puts you in a position to negotiate and put out for tender a logistics process, right? Like I
Mm,
can now negotiate with a big company and put forward a big opportunity that look, you're not just going to pick up from my farm, you're going to pick up from 20 farms,
yeah,
right? And that's a game changer in
yeah,
terms of that process, right?
yeah.
So,
It really, it does take, if you have a centralized hub handling that,
mhm.
then as a farmer, you don't have to worry about it. Like
Yeah.
it's
Yeah, yeah.
taken care of.
I call Bob,
Yeah, exactly.
right? I don't have to
Exactly.
go and try and negotiate it and figure it out and who can come pick up and how do they do it and how does it
Yeah.
work, right?
Yeah,
Um,
yeah. Hey,
yeah.
Trevor, can you jump back to your valorization
Yep.
slide there? Um, and you had that great graphic also a couple of slides ago. Yeah, let's look
This
at
one?
that. And
Yep.
so there was a question about that on the Q&A. There's a question about this area, like what's the uh, how close are these spokes to the hub? And we talked about roughly 100 kilometers. It has to be close enough to kind of service.
It has to be close
Um,
enough to make sense. I mean, this
yeah,
is
you have
always
to
going to
drive back
be
and forth. So yeah,
exactly. I think there's a discussion point. I mean, some of them are going to be 20 kilometers away, some are going to be 100 kilometers away, right? It's not going to be, you're never going to get a perfect circle, especially in Canada.
yeah,
It's just
yeah,
not going to happen. I don't think you're going to get a perfect circle anywhere in the world, to be honest.
yeah,
Unless you can go do this in Dubai and they'll just give you a circular piece of land and say go.
yeah,
But
yeah,
it's I think it's going to translate. You've talked about the 100-kilometer mark, Justin.
Mm,
I think that's a reasonable point of, managing CO2 footprint, managing transportation cost, managing that process. And I think it's going to start with the hub saying, here's where we're going to be, right?
yeah,
Or, who are the farmers that we want to play with? And maybe there's multiple sets of hubs, right? And that again
yeah,
becomes a discussion
exactly.
point, right?
Yeah, yeah,
Um,
yeah.
yeah,
So then I'll just get a couple of the other questions.
sure.
Abnav's asking about. He thought your videos looked really cool. Has anyone looked at producing biochar from the pelleted sludge at scale? And so if you go to your
Yes.
valorization pathways
Yep.
slide there,
Yep.
and then you've got um,
Pyrolysis.
yeah. So pyrolysis, like what? I don't really know that process too well, but you're heating like at a lower, no oxygen, right? So it
Yeah,
doesn't
so
burn.
the basic
Yeah.
concept of pyrolysis is you're burning without burning, right? You're creating a
Yeah.
burning environment with a zero or very low oxygen environment. So essentially what you're doing is you're breaking down all of your carbon chains into carbon, which becomes your biochar, and your
Mm-hmm.
off gas hopefully becomes methane
Methane.
and carbon monoxide,
Mm-hmm.
and that gets burnt as a syngas.
Yeah.
So the quick answer to to the pyrolysis scenario is yes, lots of people have looked at it. In fact, we went as far as hiring. We didn't hire him. We offered the opportunity for a DTU master's student to do a thesis on pyrolysis,
Hmm.
and we supported that. So it was actually kind of fun. Total sidebar, but I got to sit in on his evaluation of his thesis, and I got to grade him.
Right on.
It was a weird experience. Denmark does it completely different when you do your master's thesis, but either way,
Yeah.
um,
I know.
base
I did my
it,
master's thesis in
there
Denmark.
you go. So you had to do the
It's
presentation, and
yeah,
and
there's
you
some stress there because you
yeah, it's
work
huge.
it 100% of your mark comes down to this
It's
one
all or
this
nothing,
two
everything in an
hours.
hour and a half presentation about your life. Yes.
Yeah.
And three random people sitting in there listening to you.
Yeah. Yeah, that's right.
So the basic response to the pyrolysis scenario is one, it has high validity, I think, in the process. The downfall to it is you need a lot of product to turn it into biochar, and you need a
Hmm.
lot of consistent product. It's sort of the feed the beast mentality. And the downfall to RAS production is it tends to be volatile. It goes up and down. You have different biomasses, different waste amounts. So I can't always guarantee that I'm going to have 2,000 kilograms a day of sludge out of my facility, right? And
Hmm.
especially as a small provider, let's say I've got 200 kilograms of dry product that is turned into a pellet, and now I'm going to try and biochar that. Well, now all of a sudden my biochar is like 20 kilograms. Well, what the heck do I do with 20 kilograms of biochar?
Hmm.
Nothing.
Yeah,
It's
nothing.
there's
Yeah.
just absolutely zero value. So I think what you would see in this type of case, and it's a great point, is we could turn it to a this valorized pyrolysis product for biochar in
Hmm.
that space, right?
Hmm.
So
Yeah.
I think there is value there.
I,
Um,
how does the cement one work? Like you burn it and then
the
you
ash goes into the
ash goes
cement.
into making concrete?
Yep.
Hmm.
Ultimately, the I and I should qualify this one. Um, I know a lot of facilities, cement facilities, use what is called an alternative fuel source. I was working with a group that even had one that was called RDF, which is refuse derived fuel.
Mm.
So they were taking like waste from material recovery facilities, automobile recovery facilities. They have what they call auto fluff, which is
Hmm.
the, all the fabric and everything else it comes out of the seats and stuff, and they were selling that. The downfall that you run into is in Alberta specifically. I was actually looking at this with a refuse derived fuel, and the one cement plant is basically right outside the national park. So there's zero opportunity to use
Mm.
refuse derived fuel because the federal government's just like, no, you can use coal or coal. That's it. Like
Okay.
maybe wood chip, but
Yeah.
it's really going to change depending. But again, it's a very valid opportunity because the cement kilns usually operate above 1,000 degrees Celsius, so it burns off everything.
Yeah.
I'm not convinced it's the right answer. It's just another answer,
Okay.
right? I mean,
Yeah.
obviously, the best is trying to access that nitrogen or phosphorus in a fertilizer, or some kind of ash or biochar, bioavailability of the products, which is definitely the preference there. So.
Yeah. Yeah.
Um, Please feel free to throw more questions. Basically, we just have this one slide, which is sort of designed, looks at the value pathway a little bit differently. You cluster your farms like we talked about in that 100-kilometer range. You get design and install of modular treatment systems, so you get efficiency that's there. Each spoke is pretty standardized. From a RAS perspective, they're 300-ton models. You get 300, 600, 900, right? Which is just 300, 300, 300. The
Yeah.
waste treatment would just scale up exactly the same. So you get a lot of that efficiency in terms of how you deploy it. You get efficiency in terms of purchasing. because you're going to buy 20 of the same thing, right?
Hmm.
And then it makes it very, very simple. Then you get your centralized hub. But I think a lot of the big wins that become the side wins, but are ultimately the long term is this last one, which is knowledge sharing and integrated logistics, right? Well, what are you doing?
Hmm.
Well, what are you doing? So instead of one fish farmer operating, you now have 20 fish farmers doing things and tweaking things and playing with. And, you know,
Yeah.
regardless of how good we all think we are as engineers in design, there's always something you can tweak.
Yeah.
So
Yeah.
you
No
get
kidding.
you
It,
get 20 people tweaking it, you're gonna get the best of everything in the long run, you know?
yeah.
And
Yeah.
and mostly because you learn what doesn't work.
Hmm.
I think that's kind of the really important part, right?
No, yeah, no kidding.
In terms of that process.
No
And
kidding.
so
I think of yeah, like your one of the big areas I think of value for this type of model for both like the hub and spoke model and this um, manure handling hub and spoke model as
mhm,
well is that the monitoring aspect where you can collect data and the tools now are getting so much better than like for
yeah.
30 years we collected data on an aquaculture site, but a lot of the times you collect the data and then you don't do anything with it and you don't find these patterns, these trends, and
Well,
now
I mean,
now you can
yeah,
do that.
it's the infamous lessons learned, right? I mean,
Hmm.
how many companies out there don't have, decades of lessons learned that they've never executed on because they always forget
Yeah.
to
Yeah. Yeah.
execute them,
Yeah,
right?
exactly.
You go learn a bunch of stuff and then you forget about it, right?
Yeah.
But
So
you
now
know, I
you have a hub and then you have 20 different farms doing their manure handling.
mhm.
And yeah, you're collecting data and finding out and then you're benchmarking. You go, hey,
Yeah.
this one's working the best. When then you tweak you can tweak the other ones
Well, then
and
we can all go
everyone's
tour, right?
benefiting from it.
You can go drive around and go for a tour and make sure that they're all doing the same thing
Hmm.
and see who's doing what and why. And again, I think that's the knowledge sharing and the integrated logistics, I think would be the longest term wins as you go through this process, right? Like you're going to get a lot of the initial wins of geographic clustering and standardized equipment packages and all those things, but once it's built and done, then it's the knowledge sharing that happens afterwards. It's the integrated logistics process. It's the ability to go to tender. It's the ability to access larger markets as a small market producer, right?
Hmm.
Like, how do you distribute this product now? Are you all going to try and call up Loblaws and Safeway and or are you all going to try to go to the local farmers market or how do you distribute this as a small producer?
Hmm.
Um, if anybody on this call has ever been to SPG in Barcelona, they'll see what they're up against.
Hmm.
That seafood processing global. I mean that's where you really learn the size of the aquaculture market and what's going on.
Yeah.
The thousands and thousands of people and you see Leroy with a 20 tables set out and 20 salespeople all talking to different people. And then Salmar has the same and Cermak has the same. And, you realize, oh my God, how would I do this as a one-off 300-ton producer? I couldn't,
Hmm.
right?
That's
Um,
right.
one, I'm not going to be able to afford to go to SPG every year
Hmm.
as a 300-ton producer.
Yeah.
So, well, maybe you can. I don't know. Maybe the salmon market's going to be that good. I'm not sure.
I don't think so.
You don't think so?
It's,
You
I
don't you
mean,
don't
it's
think
tough to
there's
do any at that size. It's you're you're operating your farm, and you
yeah,
don't
you're a
have
small business you're a
you
small
don't
business
have
owner
all the
operating your farm.
extra staff, all the
Exactly.
extra overhead doesn't exist.
No, you've got, maybe one staff member
Hmm.
other than yourself and your partner.
Hmm.
And yeah, It's it's a pretty straightforward
Yeah.
process. So
Hey,
so
Trevor, what's the
so
time frame? Like if you wanted to, if you had a 300-ton farm,
hmm
and you wanted to get the equipment set up to get to that that point where you're at, um, 20% um, dry matter. How long does
like
it take to
from
get that equipment up and running?
from start to finish, you're probably about 6 months from hey, I'm ready. If you called me today and we knew nothing about the process, it'd probably be about 6 months. If
Hmm.
we have all of the initial sort of centralized hub negotiating and all of that, and it's really just an acquisition and deployment process,
Hmm.
it'd probably come down to about 2 to 3 months.
Yeah.
Because then it's just acquisition, building, and delivering, right?
Hmm. Yeah.
And we can optimize that significantly. But if it's a
Yeah.
if every
So it's
plant is going to be a bespoke, independent, oh, we have to do a PNID and PFD, and where is it going to be on your property, and what is it going to look like, and oh, you want this over here and that, then it gets complicated. But if
hmm.
everybody has the same box, here you go,
Yeah.
yeah, 3 months
Yeah.
tops, right?
Yeah.
Super
Yeah.
simple, super deployable. But I can draw it out as long as you want if you want to go full, bespoke. Oh, I want this over here in the corner, and I want 6 VFDs instead of four, and I want
Well,
7 monitoring stations and all kinds of weird things. But yeah,
yeah. So I know that, and that's where I think that that's a great example of where the hub and spoke is the adds value is that you do that on the first one and you
yes,
figure out all exactly,
we
how you
design it
want it and
once and then
stuff.
deploy 20.
Exactly. Yeah, and then the rest of
Yeah,
them just
yeah,
yeah, are just done. Hey, should we there's a few questions maybe we
yeah.
can jump into to a couple of the Q&A there. So there's someone's asking for your contact info and there it is
On the bottom of the screen.
right on the slide there. Um, so, perfect. Here's one. It's not necessarily, well, I guess it relates to the amount of manure production. Uh, um, Bill's asking, what is the RAS farm density in Canada and US? And I guess you can take that two ways. Is it the density of fish that you're growing, or is it how dense are the farms around each other?
Yeah,
So,
fair.
so yeah, so fish, fish density, that's different, I think, at every farm, at every, with every technology. And I think it all comes down to water quality. If you can maintain the water quality, then your density is probably good.
That's yeah. That's
So,
sort of a beyond Trevor's If you want to know the density of dry sludge, it's about, that dry particle has a density of about zero point 0.6
yeah,
kilograms per cubic meter. Um,
yeah,
but after that, how
yeah,
dense are the fish in that farm? That's ultimately going to come down to the
yeah,
RAS design and how good
yeah,
Justin and Habitat do their job.
yeah, yeah. So, but here's a follow-up. So, Abhinav's asking, a similar question here. Are there enough sites near one another for this model to work in North America? And Europe seems to be better suited to this for this model. And so the answer
I
is
think I would
not
actually
yet, I
disagree.
don't
I think
think.
Canada, I
Oh,
think Canada and North America is better suited to this model in some ways.
yeah,
Um,
yeah. I mean, I think it's well suited for the model to develop, but those farms don't exist yet.
no, well, that's the thing, right? Is
Hmm.
so let's pick interior BC. Say somebody
Yeah.
decides, okay, the hub is going to be in Kamloops,
Hmm.
right? I think it's easier to go find 20 pieces of land where I could put 20 300-ton head-on gutted facilities in a 100-kilometer radius than
Mm,
it would be to do in Denmark. I think that would be very difficult to achieve in Denmark in terms of finding a hub and then finding 20 independent 100-kilometer away facilities where I could put these spokes, right? I think that's actually more complicated in a European market in some ways versus the North American, where I've got big highways, I've got lots of secondary highways, I've got good logistics from a transportation perspective.
hmm.
And I think again, if you pick like a Kamloops, a Kelowna, I wouldn't pick Vancouver as my hub. That might not make sense because it's expensive.
Yeah.
Um, I might also not pick Smithers
Hmm.
as my hub.
Hmm.
But maybe there's a point in Alberta where you pick a Peace River
Yeah.
as your hub, right?
Yeah.
Maybe there's a Athabasca in Alberta.
Yeah.
But again, you've got I don't know. I think it's actually better suited to North America when I think about it. Um,
Hmm.
but I could be wrong.
Yeah. Yeah, I think that I think there's a lot of opportunity there. Yeah, the more you dig into it, different locations make sense. But
Hmm.
for sure, right now, when you look at North America, yeah, those farms within that proximity of each other, that's a model that's being developed that's not here right now.
Yeah,
Um,
I guess the secondary follow-up question to that, and again, this isn't something that I would necessarily have the answer for, but it poses a question to my head is it easier for a 300-ton head-on gutted facility to get their environmental discharge permit than a 30,000-ton head-on gutted facility, right? Because now I'm only dealing in 2 to 5 cubes an hour
mhm,
of wastewater versus, 200 cubes an hour of wastewater. I'm
mhm,
significantly less relevant,
mhm.
but I'm also
Yeah,
going to have a lot of backup information and support documentation from the hub to be able to go get that permit. And so
yeah.
I don't know, it gets interesting. I'm not sure what the answer ultimately is in that space, but
Hmm.
I would venture to guess that it's significantly easier to get a discharge permit for 2 to 5 cubes than it is for 200 cubes.
Hmm. Yeah, yeah, I agree with that. So a few other questions. What happens if the farms are producing at different salinities? Can this affect the centralized hub? And so the current models for freshwater,
Hmm.
um, yeah. But yeah,
I mean, from a
probably.
wastewater perspective, not really.
Okay.
Where like from a solid liquid separation perspective, salinity, yeah, it can impact your chemistry treatment, your dewatering process, no impact. Your solid liquid mechanical perspective, again, no impact. When you're drying the sludge, again, it really doesn't have a ton of impact. Where the salinity is going to matter is on your discharge permit. Can you discharge saline water with a salinity, right? Can you put chloride in that water? Um, and then secondary, when you have salinity in the water, a good portion of that salinity will end up in the dry product. So
Yeah.
then that can impact what your potential uses of fertilizer, biogas, all of those things. Again, it's not going to be massively detrimental. It's
Hmm.
just something that everybody needs to be aware of. But
Yeah.
in this case, we're dealing in freshwater, so it's not a big deal. But I think if you're looking at a centralized hub and, five are producing coho, five are producing Atlantic, five are producing grouper, five are
Hmm.
producing kingfish, yeah, then you've got a different scenario.
Yeah. Yeah.
And I think that might be a longer term future of something like this. Whereas, right now the concept is no, I'm just getting coho salmon, right?
Yeah. Yeah. Yeah.
I'm not going to try and dig into 16 different species and some bivalves.
Hmm. Yeah. Yeah, I mean we could talk about this forever. Hey, we're at the top of the hour. Just super quickly, a couple more questions. What's the footprint from Ben? What was the footprint required? For
At that small stage,
yeah,
basically
bespoke.
you're essentially looking at a need for sort of it would fit in a 20-foot container, if that
Yeah,
helps
yeah,
concept. We
yeah,
could containerize it and drop it off if need be. Obviously the preference is inside a tent or some kind of building. But yeah, conceptually a 20-foot container would house this no problem.
yeah, yeah. Yeah, good. Hey, there's sorry, we didn't get through all of the questions here, but we are at the top of the hour, so I'd just like to thank Trevor here all the way from Hersholm, Denmark, part of Denmark, Greenland, still part of Denmark.
Yeah, it is. We didn't lose
And
it.
yeah,
Canada's still part of Canada too.
yeah, it's exactly. Thanks. So thanks for everyone. Thanks for attending. Here's Trevor's contact coordinates there. You can also look him up on LinkedIn, or you can visit him at his booth at the RASTech conference coming up
Correct.
in a couple of weeks.
Correct. I'll also be doing a presentation at RasTech, which is a semi follow-up, and you kind of identified this too, Justin, is when do I involve Trevor and or the wastewater treatment guys? And the answer is sooner rather than later.
Yeah, yeah, exactly. Don't wait. Don't. It
Do
shouldn't be an
not wait.
afterthought.
Yes.
Yeah,
That does happen quite regularly. Oh, crap. Yeah, we got this environmental permit that drives the whole bus, but we forgot to talk to those guys.
yeah, yeah, yeah.
So
Good. And then, so this presentation will be available,
that's up
recorded,
to
right,
Alex.
Alex?
Alex can tell us that side of things.
Yeah,
Awesome.
yeah.
Just want to thank you guys once again for being here today. That was great and very informative. That does bring us to the end of today's webinar. Just wanted to once again thank Illumichem for sponsoring the webinar today and thank all of you for taking the time to join us. Just a reminder that an email will be going out tomorrow with a link to the recording. I hope everybody enjoys the rest of your day and have a great day.
Thanks, everyone.
Thanks,
Appreciate your time.
everybody.
Have a good one.